stress over those too much. They're kind of statistical sampling questions for the QEP. If you get them right, it's a bonus. If you get them wrong, it doesn't affect your score. These are the items that are on the final exam. We switch over to the outline here. I want to go over the general ideas so that we understand what the plan is for the types of questions that will be on the test. Remember, you can bring your 8.5 by 11 sheet of paper, whatever information you want on it. On the non-parametric, which remember is things like the runs test, manually U, when I say recognize the advantages and the disadvantages, there's a slide that talks about it being wasteful of data, that it's distribution free, all of those things. Make sure you understand what those things are and why they're important. Then it says, understand how to use the test for ranges. What is the test for ranges? Who presented the case on Tuesday? Okay. It's the runs test, right? That test for ranges. So that's a multiple choice question right on that side. Which test do we use for ranges? So let's say like runs, Wilcox smoothing, manual review, so on. It's the runs test. The runs test. Then it says know when and how to use manual U test, the Wilcox fair test, the Kruskal-Wallis, the breathing test. In other words, there are at least a minimum of 2 questions on every one of the tests that I've listed here. And there's 2 flavors of question. Flavor 1 of the question is, what situation do I use this particular test in? Or what does this particular test tell me? Or what does this particular test compare to in the parametric order? In other words, of these tests listed here, which one is similar to an ANOVA? You guys did this yesterday. The manual U test, right? So those are the types of, that's the first flavor of question. Second flavor of question is to actually do something using the technique. Either there's a small little sample set, or there might be an output, similar to the Reebok case. Remember how we had the output where it said K was this, and all of these things, right, the p-value and all that, and then drawing a conclusion. In order to get that right, you have to know what the null hypothesis is supposed to be, right? And the answers are like, reject the null hypothesis, they're all equal, accept the null hypothesis, they're all equal, reject the alternative hypothesis, right? Then on the quality control. When I talk about general concepts of quality control, quality management software, remember there were like 5 slides that listed Deming's 14 principles and all of these different things. At the end of the day, make sure you just have, don't try and memorize the list is what I'm suggesting. Rather have a general understanding of what is the idea behind quality. And quite succinctly, it is to move away from detecting defects after they've happened towards having a system that prevents the defect from occurring. Right? That's the general view of quality today. Prevent the defect from happening. Don't spend a bunch of money trying to inspect or catch the defect after it's happened. That's the broad general idea. All right? Why is statistical quality control used? Why is it important? Again, those control charts allow me to detect that we're starting to go out of control. I can stop it before it actually becomes an error. When I was driving down the road, actually, I was thinking about that the other day. Have you ever been on 37 south of town? And they etch the concrete, so if you get too far out, the car starts going like that, right? You haven't actually run off the road at that point, then it's a warning sign that you're having problems, right? Same situation with the control charts, right? You haven't gotten into a wreck yet, but it's indicating bad things are about to happen, right? And then what can you do? Oh, bending the steer back in the lane, right? Okay. What are the process analysis tools? Pareto chart, Hirosaki diagram or fishbone diagram, process map, all of those types of things, right? And it should be a review from steps 1 on some of those issues, but make sure you understand what it is. For example, what is a Pareto chart attempting to do? Quantify which item is causing the most defects, the second most defects, and the third most defects, right? What is the cause and effect diagram? Attempting to brainstorm root causes based on different categories, man, material, machinery, method. There's different flavors of that as I talked about. Breaking it apart, what's causing it, root cause analysis. And then, how do we construct the various charts? What does the X-bar chart look like, and how do I construct it? You don't have to necessarily calculate, okay, this is the X-bar upper and lower performance using an A table, right? But generally speaking, how do I get an X-bar chart? I take a bunch of samples, I average each of the samples, and I take the super mean or the average of the averages, right? That's what the X-bar is. What's the average of a bunch of samples? And then the plus or minus is 3 standard deviations, right? It's a 99.7% confidence, 3 standard deviations. What is the range chart from? The range of a bunch of samples, right? So I take sample 1, 2, 3, 4, here's the range, average all the ranges, and then plus or minus the standard deviation. The X and the R chart work together, right? Because if I know that all of my samples average 10, it doesn't guarantee it's on-spec product, because I could have empty and 20-ounce jars, right? It still averages to 20, but none of that's on-spec. So I have to not only have the average correct, but I don't want a lot of spread, which is the measure of range. And as a question, why do we use range instead of standard deviation? Because it's easier to calculate, right? It would be tough for a guy on the shop floor to pick up 20 cans and say, okay, the lowest was 8, the highest was 12, that's a range of 4. We don't need to calculate that, right? But if we're going to figure out standard deviation, how would we do that? What's the average minus each point, square it, divide by n minus 1? Too much work, right? So we use a range to make it easy for people on the floor to handle. And then what about the P and the C chart? P is a percentage or proportion chart, right? Percentage of defects that occur. And we saw a demonstration of that on Tuesday, right? The formula for that is easy, doesn't require a table, and will be something you can calculate on the test. As a hint, I would put the formulary for calculating a P chart on your sheet. Remember, basically, I take the percentage of defects that I think, which is P, and then I take the Q, which is the percentage I don't think, right? So if I have 8% defect, P, then Q would be 92%. Multiply those together, basically, to get my mid-range, right? And then we have the C chart, which is a count, C for count. Counts the number of defects that are occurring. Remember, this is typically out of a larger item, like a truck or something. It has a defective windshield, it has seats, whatever. I count the total defects per item per bench. And that is a simple formula as well. There's not a plus or minus, it's basically 3C formula. Then, not to calculate acceptance sampling, to calculate, but understand what acceptance sampling is and why I would use it. Remember, this is where we had a little bike example. It's using the binomial distribution, which you don't have to calculate, so don't waste your time trying to figure that out. But at the end of the day, what is it really telling? And what is the risk to the supplier and the buyer? And how does that change as the level of sampling goes up or down? Remember, the idea is there could be bad product or there could be good product. We don't know unless we take a census and count everything, right? But that's not always possible. So if I don't sample at all, who has all the risk? If I sample a lot of stuff, who has the risk and so forth? And remember, this is like that prisoner's dilemma. There's 4 boxes, 2 choices are the right decision, 2 choices are not the right decision, type 1, type 2 error. One is borne by the seller, one is borne by the buyer. Again, not calculating, but understanding. And then finally, the time series situation. What are the 4 items in the time series? Trend, seasonality, cyclicality, irregular factor. Know what those look like, right? Trend is overall rising or decaying over time, seasonality, short-term up or down, cyclicality, long-term up or down, and then irregular factor, just random error, right? Know which techniques apply to those components. In other words, if I'm trying to forecast a trend, what technique do I use? Regression. If I'm trying to forecast irregular factor, or eliminate the irregular factor, what type of forecasting do I use? Some kind of smoothing method. Exponential smoothing, weighted moving average, simple moving average. If I'm trying to forecast seasonality, what do I use? Centered moving average, right? Remember, I take the centered moving average, basically here's July, I take 12 months around that, get an average, right? Remember how we did that? I think we did that. All right, what is a stationary forecasting technique? Or sometimes referred to as naive method. What I did last time, right? What else? Delphi technique, it's a survey panel of experts. The book talked about that, we didn't really spend much time on it, because it's a qualitative forecasting technique. But basically I say, all right, you've done this for a million years, what do you think? And he tells me we'll sell 10 million, I come over here, what do you think? We'll sell 11 million. And then I give them the results anonymously, saying, here's what everybody thought, would you like to revise your answer? And sold in the group.